Okay. Model houses, planes, cars, trains are all kept in some sort of proportion. So let's have a look at this example where we're looking at a model plane. So this one's got a wingspan of 80 centimeters, and it's telling us the ratio that keeps this plane in proportion to the real plane is 1 to 20. We want to know what the real length of the wingspan is if the actual of the real plane. So we've got 80 centimeters for the model. So we know that for every centimeter should be 20 times larger in reality. So let's do 80, which is the number of centimeters of our model, times that by 20, and that will give us 1,600. That's going to be centimeters, of course. Now we want our answer in meters, so always look for the unit. So there is 100 centimeters in a meter, so we're going to divide by 100, and that means that we're going to get a final answer of 16 meters. The next question follows the same scenario. So we've got this 1 to 20 ratio for keeping this model plane in proportion, but this time we're looking at the area of the model. Now, with proportion, essentially what we've got there is a scale factor. Okay, so the real plane is 20 times bigger than the smaller plane, and we're going to use that to increase areas and the question below, volumes. Okay, and it's a simple strategy for doing that. So we know that 5 meters squared is in ratio to 20, but when we're talking about area, we want to scale our square factor, our scale factor. So we want to square our 20. So really, where we would have done the 5 meters and divided by 20, we're going to do 5 meters divided by 20 squared. So actually that becomes 5 divided by 400, which is going to give us a very small number of 0.0125, and that's meters, of course. And I can leave my answer like that, but let's just show you how to convert whilst we're here. So let's say the answer wanted it in centimeters instead. So to go from square meters to square centimeters, as we already said, there's 100 centimeters in a meter. But if we're looking at area, we've also got to think about squaring that, because that's essentially another scale factor. So 100 squared is going to give us 10,000. So if we multiply our answer by 10,000, we'll end up with 125 centimeters squared as the area of our model plane. Okay, and we're going to do something similar for the volume question at the bottom. So this time we've got 150 centimeters cubed being the volume of the model, okay, and we want to know what's the volume of the real plane. Let's have a look at what this one would work out to be. So if we've got 150, again, if it was just the length, we would just be dividing by 20, but we're not. We're going to be looking at the volume. So where it was area, and we write things in like centimeters squared or meters squared, where it's volumes, we write things in centimeters cubed or meters cubed. And that should give us a trigger that what we need to do is cube our scale factor. So we're actually going to divide by, I'm going from the model, apologies. I'm going from the model to the plane, so I'm going to get larger. So I'm actually going to multiply here, not divide, apologies. So I'm going to do 150. I'm going to multiply that by 20 cubed, which will give me 8,000. And that gives me an answer of 1,200,000. And of course that's going to be in centimeters cubed. Similar to the previous one, let's convert this into a more rational value. Let's convert this into meters cubed. So if we're going to go from centimeters cubed to meters cubed, we're going to use a scale factor of 100 still, but because we're talking about volumes, we're going to cube that. So we're going to do 100 cubed. 100 times 100 times 100 is in fact 1,000,000. So we're going to divide our answer by 1,000,000. Let's see if we can squeeze that in. And that should then convert our answer to 1.2 metres cubed. A very small cockpit indeed.